So today we are going to start. Today we are going to learn simple harmonic motion and elasticity. So first I am starting with SHM, simple harmonic motion. So first we'll understand what is periodic motion. So if a system repeat its motion after a fixed interval of time, then the motion is called periodic motion. Like you can say the motion of Earth around the sun. So when a motion is, what is basic criteria here? The motion should be repeated after a fixed interval of time. That is called periodic motion. Then oscillation. So what is oscillation? When a system repeats its motion about a fixed point, then that motion is called oscillation. What is simple harmonic motion? So simple harmonic motion is what? When a system repeat its motion after a fixed interval of time, after a fixed interval of time, and its motion is its motion is when a system repeats its motion about a fixed point, about a fixed point at a regular interval of time, in such a way that its acceleration is always towards a fixed point, towards a fixed point, and is proportional to its displacement from the fixed point. So basic idea is when a system is repeating its motion and its motion is repeating its motion about a fixed point. Like when I say periodic motion, it is orbiting about means what Earth orbits around the sun. But when I'm saying the system is repeating its motion, means if I take suppose a platform is there. On this platform, there is a block. There is a block, and we have connected a spring. So if we extend the spring and leave it, it will oscillates above this fixed point, above the point where force is zero. Net force is zero. So it will be called SHM. When first I have explained you what is the meaning of repeat its motion about a fixed point and a regular interval of time. This will be the fixed point, and if it's a repeat its motion after a fixed interval of time about this point. After this, what should be the condition? Acceleration should always towards the fixed point. It means when the object is moving in this direction, its acceleration should be in this direction. When the object is here, acceleration should be in this direction. Then it will be SHM. One more condition is there. Its acceleration should be proportional to the displacement from the fixed point. So if we combine these all things, so we can write one equation. A is equals to A should be proportional to minus x. So if we remove this sign, A will be equals to minus omega square x. So this equation we use, to further define the equation for SHM. So here A is what? Acceleration of the system. X is what? Position from mean position. If we further use this relation, then we'll get the equation for SHM as x is equals to A sine omega t plus 5. Like we had equation in kinematics, V equals to U plus AT for constant acceleration motion. Same way, this is a SHM, which is simple harmonic motion. It is a type of motion where these conditions should meet. It should repeat its motion after a fixed interval of time. Its motion should be about a fixed point. Its acceleration should always towards the fixed point, and its acceleration should be proportional to the displacement from that fixed point. If these four conditions satisfy, then only we can call this motion as SHM. But if you remember in kinematics, we had only one condition that uh, acceleration should be constant. Then we used to get V equals to U plus AT, S equals to UT plus half AT square. So here we have the different condition. Here acceleration is minus omega squared x. If we derive this equation, if we simplify further, we get the equation in this form. So in this equation, what it is? Here x is position of the particle with respect to mean position. A is what? Amplitude of the particle. Omega here is what? This omega and this omega is same. So omega here is angular frequency of the system. What is Write this as delta. What is delta here? Delta is phase constant. So there are many terms involved in this SHM equation, so we'll try to understand all these terms one by one. So what is amplitude? Amplitude is maximum displacement from the mean position. Next, one term here I have used phase. What is phase? So phase we represent it defines the state of motion. Means at any point what is the speed of particle, what is the position of the particle. So what is basically phase? Phase we represent by phi, that is omega t plus delta. So if we write phi is equals to suppose pi by 2, so see our equation at any instant if phi is pi by 2, so our equation x equals to a sine omega t plus delta omega t plus delta is phi. So x equals to a sine pi by 2 a. If phi is equals to 0, x will be equals to a sine omega t plus phi plus delta. So here if I put 0, I'll get a 0. It means position of the particle at that instant is where? At the origin or at the mean position. If phi is equals to pi by 4, so what I'll write? X is equals to a sine omega t plus phi. A sine pi by 4, so a by root 2. So basically this phase explains the state of motion, where the particle is, what is its velocity, what is its acceleration. Then one term we have used here, angular frequency. What is angular frequency? Angular frequency is the characteristic property of the system. Property of the system. Then one more term we have used here, phase constant. What is phase constant? Phase constant. Phase constant gives the idea about initial state of motion. Initial state of motion. At t equals to 0, what was the position of the particle? What was the velocity of the particle? What was the acceleration of the particle? So like ax equals to a sine omega t plus delta. Phase constant is what? Delta. So see at t equals to 0, what will be the equation? Because see phase constant give what? Idea about initial state of motion, means at t equals to 0. So x equals to a sine delta. So if delta is equals to pi by 2, means what? X is equals to a. Means initially at t equals to 0, particle was what? At the positive extreme. If delta is equals to minus pi by 2, what do you mean? X is equals to minus a by 2, means what? Particle is at the negative extreme. At delta is equals to 0, at t equals to 0, means from where motion is starting. Suppose if delta is equals to 0, x equals to 0, means what? Motion is starting from where? Motion is starting from the mean position. So these are the equation. These are the different parameters for this SHM equations. But equation that we have written, it is applicable only for the position of the particle. So if for position of the particle, we are getting the equation x equals to a sine omega t plus delta. So if I differentiate this equation, what I will get? V is equals to dx by dt. So I will get a omega cos omega t plus delta. If I differentiate it again, velocity equation, a equals to dv by dt. So what I will get here? Minus a omega squared sine omega t plus delta. If we draw the diagram for each position with respect to time, so what will you get here? Suppose I am drawing position with respect to time, and I am drawing for delta is equals to 0. So motion will start from in position. Okay. This way it will go. If I draw for same delta equals to 0 for same particle, velocity time graph, see velocity cost term is involved. Means what? Motion will start and it will keep on happening in this manner. If I draw acceleration time graph, this was VT graph. If I draw acceleration time graph, what it would be? See, this is acceleration, this is time. See, here minus sign is there. So it will start from negative direction. So this is the difference. So if you see this, you can say phase difference between the velocity and the position is pi by 2. Phase difference between position and the acceleration is pi. Phase difference velocity and acceleration is pi by 2. So these were the equation of motion for the SHM. Few more equations are there that will be really helpful for the SHM. One equation is V equals to omega a square minus x square. This relation also, if you manipulate above equation, you can get. Let's do some question based on this SHM topic. So first, this equation question we have. They have given the equation of a particle executing simple harmonic motion is x equals to 5 sine pi second inverse plus pi by 3. Write down the amplitude, time period, and maximum speed. Also find velocity at t equals to 1 second. So see then, what we can say, the amplitude is 5, omega is pi. How I'm writing this? I'm comparing the above equation with x equals to a sine omega t plus delta. A is equals to 5, omega is equals to pi, and delta is equals to pi by 3. So amplitude we got how much? 5. Omega I got. Maximum speed they're asking. So see our equation, v equals to a omega cos omega t plus delta. So if I want to find the maximum value, so maximum value for cos omega t plus delta will be how much? It will be 1. So what we can write? We can write v max will be equals to a omega. So 5 pi meter per second. How to calculate time period? Time period is defined as 2 pi by omega. So what we can write? 2 pi omega we have pi. So 2 seconds. So amplitude we got, time period we got, maximum speed you got. They're asking also find velocity at t equals to 1 second. So if you know position equation, velocity, what we can write? V I can write as dx by dt. So this equation will become how much? 5 pi into cos pi t plus pi by 3. So at t equals to 1 second, v will become how much? 5 pi plus cos pi plus pi by 3. So this will become 5 pi cos 4 pi by 3. This will be minus cos pi by 3. So this will come as 1 by minus 1 by 2. So minus 5 pi by 2 meter per second. Negative sign means what? It is moving in opposite direction of our given axis, or whatever positive axis we have taken. So this is how we are supposed to approach the problem related to this equation of SHM. Whatever equation you have given, compare them with the given with the equation x equals to a sin omega t. By comparing, we will get these values. Once you get this value, remaining data as you can find out. Let's take one more. See, we have given a particle having mass 10 gram oscillates according to the equation x equals to 2 sine 100 plus pi by 6. Find the amplitude, time period, and the spring constant. See then, a particle is there, it is following this equation. So compare this equation x equals to a sine omega t plus delta. So amplitude is 2 centimeters, so 2 into 10 to the power minus 2 meter. Omega is 100. Delta is how much? Pi by 6. They're asking find the amplitude. So amplitude we got. Time period, how we can figure out? Time period is equals to 2 pi by omega. So 2 pi by 100. So pi by 50 second. Spring constant. Now see here, the position and the velocity on this thing. See, spring constant we write k equals to omega by m. So try to understand how this equation we can write. We know time period equals to what? 2 pi by omega. So in case of a spring, suppose a spring is there, it is hanging, mass mg would be acting, initial will be kx naught. From the equilibrium position, if I brought down it by x, so what I can write the net force? Net force will be, from the equilibrium position I have brought it down by x, kx naught plus x minus mg. Net force is equals to mass into acceleration, this will become kx. So A is equals to k by m into x. So omega will become how much? Root under k by m. Omega we know. So pi by 50. How I got k by m? I have compared this equation with a equals to omega square x. Magnitude of the acceleration. So pi by 50, that is omega. Mass we have given is 10 gram. So k 10 into 10 to the power minus 3. So this will come as pi by 50 into pi by 50. This will be k by 10 to the power minus 2. Simplify this, that will give us the answer. See, second thing they're asking, the position, velocity, and acceleration at t equals to 0. So if I want to find velocity, what I have to do? I have to differentiate the equation. So v I'll get as how much? V I'll get as 0.02 into 100 cos 100t plus how much it is? Pi by 6. If I find out the acceleration, I have to differentiate it again. So 0.02 into 100 square minus sign will come differentiation of cos. So 100t plus pi by 6. So at t equals to 0 if I write, so what will become the velocity? Velocity I can write as 0.02 into 100 into cos pi by 6. Cos pi by 6 is root 3 by 2. So this will come as root 3 meter per second. At t equals to 0, acceleration will be how much? Minus 0.02. 0.02 into 100 square. 100 into 100. Now sine pi by 6. Sine pi by 6 will become 1 by 2. So 0.01. So this I can write as minus 100 meter per second square. See these type of question how we are supposed to approach. First we'll compare the given equation with standard equation of SHM x equals to a sin omega t plus delta. Then after comparing those equations, we'll get the different values. Unknown values we can find out by the remaining formulas, remaining concepts. Let's take one more question, a little bit different one. See this one. They have been consider a simple harmonic motion of time period t. Calculate the time taken for the displacement to change the value from half of the amplitude to the amplitude. So suppose if I take a circle, so this is the easier way to do the problem related to phase diagram. Whenever you have to calculate the time or calculate the phase constant, this way doing the problem is easier. The normal way also we can do the equation method. So first see this, they have can calculate the time taken for the particle to a displacement to change value from half to the amplitude. So initial particle was here, now particle is here. So initially, how we draw this phase diagram? By taking the amplitude, we draw a circle. By taking the amplitude, we draw a circle. This line represents the mean position. So projection of this position vector, this amplitude vector on the y-axis give the SHM. At any instant, suppose it started from the mean position, at any instant, if it is moving with angular velocity omega, this amplitude vector is rotating in this plane with the angle omega. So at any instant, how much angle it will form? Omega t. So here its projection will be a sin omega t. So they have given, consider a simple harmonic motion of time period t. Calculate the time taken for the displacement to change value. Change value half the amplitude to the amplitude. So this angle, if I write, how much it will be? They have given initially this value is a by 2. So if suppose I write this as theta, so theta value will be equals to, or so sin theta. Sin theta value will be equals to how much? A by 2 by a, because this is amplitude vector, this is a, and this perpendicular is a by 2. So this is coming as 1 by 2. So theta I can write as pi by 6. This amplitude means how much angle it is? 90 degree. So how much angle it has to travel? It has to travel an angle of del theta will be equals to how much? Pi by 3. Pi by 2 minus pi by 6. So pi by 3. So if you want to calculate the time period, so this will be given by how much? Del theta by omega. So how much it is? Pi by 3. And omega, what I can write? If they have given time period, omega is equals to 2 pi by t. So answer will become t by 6. This is how we can approach these problems. One way we can do these problems is by the equation method that we write this equation x equals to a sine omega t, starting from mean position. So for theta 1 is how much? Its initial position is not theta 1. For t equals to 0, its position is a by 2. So a by 2 is equals to a sine omega t. So sine omega t is equals to pi by 6. Sorry, pi, yes, pi by 6, 1 by 2. So sine pi by 6. So omega t is equals to pi by 6. So 2 pi by t into t is equals to pi by 6. So t will become t by 12. And it will reach its amplitude in how much time? T by 4. How? A particle, suppose its motion started at x equals to 0, t equals to 0. At plus a, it will be at t equals to t by 4. It will come back here at t equals to t by 2. It will reach here minus a at t equals to 3t by 4. And it will come back here at t equals to t. This is how the motion will flow. So we can say for x equals to a, for x equals to a, t is equals to t by 4. So what we can write the difference, delta t, t by 4 minus t by 12. So 3. So 2t by 12. So this will become how much? T by 6. So this is how we are supposed to approach. You can approach by the phase diagram method, or you can approach it by this normal equation method, whatever equation you like. Let's understand. Let's take one more question. Suppose if I take this question here. So we need to calculate the time period. So when the springs are in series, so what we write, K equivalent K1 K2 by K1 plus K2. When spring are in series, when spring are in parallel, what it is? I have written for 2 spring. When spring are in parallel, K equivalent I can write as K1 plus K2. Basically this relation comes from, for series I can write 1 by K equivalent is 1 by K1 plus 1 by K2 to what? Plus 1 by Kn. For parallel, K equivalent you can write as K1 plus K2 to what? Kn. Now, so for case A, if I solve, so what we can say here these two are in series. So K equivalent is how much? K1 plus K2. And what we got here in this equation, time period for spring, omega I got. Omega in case of spring we write m by K equivalent. K we got m by K, right? So omega is equals to K by m. So K equivalent by m. So time period will become how much? 2 pi by omega. So 2 pi into root under m by K equivalent. So in case A, the K equivalent is coming as how much? M by K1 plus K2. If I say in case of case B, so for case B, I can write K equivalent will become how much? K1 plus K2 because both are in parallel. So time period will become 2 pi by omega. So 2 pi into root under m by k1 plus k2. For case C, if I take, they are in what? They are in series now. So in case 3, the k equivalent will become k1 k2 by k1 plus k2. So time period I can write 2 pi by omega. So 2 pi into root under m by k1 k2 by k1. Wait a minute. So k1 k2 by k1 plus k2. So this is the thing. Let's take one more. Let's take one more question. See, we have given this arrangement, and for this arrangement we need to calculate the time period. Find t. So here if you see this k2 and k3 are in series, so k equivalent if I write, it will come as k1 plus k2 k3 by k2 plus k3. This one, these two are in series and they are in parallel with which one? K1. So that's how I got this. So time period will be how much? 2 pi by 2 pi root under m by k equivalent. So this will come as how much? 2 pi into root under m divided by k1 into k2 take k3 by k2 plus k3. So this is how we are supposed to approach the problem. Now let's start simple pendulum. So what is simple pendulum? Suppose any mass is there. It is hanging from a light string. Light string means the mass of the string should be negligible. If I displace it from that position to this position, then this angle will be what? Theta. See this simple pendulum, I can explain this same equation with the linear SHM, and we can understand the same concept with angular SHM. So see, we'll try to understand this concept with both. So let me define you the angular SHM. Angular simple harmonic. Linear simple harmonic, A was proportional to what? X. Here A is proportional to alpha is proportional to minus omega square theta. So if we derive here, we'll get equation in the same format. Theta equals to theta naught sine omega t plus delta. Beta equals to beta naught cos omega t plus delta. Alpha equals to alpha naught minus sine omega t plus delta. What is here theta? Theta is angular displacement. What is beta here? Angular velocity. What is alpha here? Angular acceleration. Remaining terms already understood. So if we take this simple pendulum, so what are the forces acting on this mg? On this mg, a force is acting here, mg sine theta, because this component will be what? Mg cos theta. This component will be mg cos theta. So torque, what you can write? Torque you can write mg sine theta into L. And torque, what we write? Torque equals to I alpha. So mg sine theta into L is equals to I alpha. So for small theta, what I can write? ml square alpha equals to mg L into theta, ll done, done. So alpha I can write g by L into theta. So omega square you can write as g by L. So time period I can write as 2 pi by omega. So for a simple pendulum, time period will be how much? 2 pi root under L by g. But see, for a spring pendulum, the time period value is constant. But it does not depend on the location, position, or how the platform is moving. But in case of a simple pendulum, time period vary with the external factor like how the platform is moving, what is the position, where it is, because the g value affect the time period. So we can write a spring pendulum time period is independent of constant external force. Constant external force. What do you mean by that? A spring does the simple harmonic motion. So whether I measure the spring time period in this configuration, whether I measure the spring time period in this configuration, or whether I measure the spring time period in this configuration, in all the possibility, in all these cases, the time period is going to be the same value, 2 pi root under m by k. But in case of simple pendulum, the situation change. For a simple pendulum, time period is function of medium, location, motion of the platform, all the external factor, whatever that may exert some external force, that may lead to change in the time period of the simple pendulum. So how all these factors can be defined in one form? So if you want to write in one form how this all time period will vary, so L by G effective, whatever the net effective gravity you can say, or net effective acceleration, that will give the time period. Let's take few example. Suppose if I take a lift is there, inside this ball is there, and this lift is going up. If this is a simple pendulum, it is moving with a constant velocity. In this case, time period will be nothing, 2 pi root under L by G. If I take case 2, suppose there is a lift, but now it is going up with acceleration a, and a mass is hanging here. So T equals to 2 pi root under L by G effective. So G plus A. Case 3, if I take, instead of going up, if it goes down, here you can write time period equals to 2 pi root under L by G minus. I have given you three conditions in those cases how the time period of this simple pendulum will vary, but in case of spring pendulum it remains constant. Let's take few questions based on this. So they have given a pendulum having time period equal to 2 seconds is called a second pendulum. Those used in pendulum clocks are of this type. Find the length of this. So time period is given by how much? 2 pi root under L by G. Its time period is 2 seconds. So 2 pi root under L by G. G value is approximately pi square. So L value will become 1. Let's understand now physical pendulum. Before this we have learned simple pendulum. So what is physical pendulum? Suppose any rigid body is there. It is hanged from somewhere. So if center mass in line here, it will remain in equilibrium. But if we displace the body in any direction, so what will happen? That may lead to oscillation. Suppose I shifted the center of mass here. In that case, that will lead to what? That will lead to the oscillation. So again, the same idea. What? Mg sin alpha. Now here we define this distance LC. What is LC? LC is the distance of the center of mass from the point of hanging, where the body is hanged. So here we can write the torque is equals to I alpha. I can write mg sin alpha into LC is equals to I alpha. So I can write mg LC sin alpha. Now moment of inertia will be what? And moment of inertia is about depends on the axis of rotation. So moment of inertia is about what? Here I is moment of inertia about point of suspension. So what it would be, whatever it is, I into alpha. So for a smaller angle, for a small alpha, I can write mglc into alpha. Oh wait, I have taken both the things at the same. It will create a problem. I'll take this as a theta. So sine theta, theta, and theta. So theta will become how much? I by mglc into alpha. Compare with theta equals to alpha equals to omega square theta, correct? We have got the equation alpha equals to omega square theta. So I'll write in reverse way. This you can write as alpha equals to mglc by I into theta. So omega will become mglc by I. So time period, what we can write? Time period we can write 2 pi by omega. So 2 pi root under I by mglc. So this is how a physical pendulum means what? It could be any object, like a ring, anything it could be. And if it is hand, if we move its center of mass little bit, it will start oscillating. And if the angle of oscillation, the angle it makes with the vertical, if it's very small, in that case it will do the SHM, and its time period will be given by t equals to 2 pi root under I by mglc. Let's take few problems based on this. See, we have given find the time period of small oscillation of the following system. Emitter is stick suspended through the 20 centimeter mark. See part A. There is a emitter stick and it is suspended through 20 centimeter mark. So somewhere here, from here 20 centimeter. Its center of mass will be at 50 centimeter. So this distance is how much? 30 centimeter. So what will be the moment of inertia? So I can write as how much? Suppose this total length is, it's a meter stick. So if I say 10 centimeter is equivalent to L naught. So what I can write moment of inertia? Above the center of mass, it is m L naught square by 12. Take the whole length as L naught. 100 centimeter is equals to L naught. Meter stick length is 100 centimeter. Plus from parallel axis theorem, because we need the moment of inertia about the point of suspension. So how much this will become? 30 centimeter. 30 centimeter will become 3L by 10. So m into 9L naught square by how much? 100. So this is our moment of inertia. So if I want to calculate the time period, so time period is 2 pi root under what it is I by mglc. So I by mglc. So 2 pi root under how much? ml naught square by 12. 9 ml naught square by 100 by this will become how much? M into G, and LC will become how much? 3L naught by 10. This distance 30 centimeter, I can write 3L naught by 10. So if you simplify this, whatever we will get, that will be our answer. See the second part of the question. A ring of mass m and radius r suspended through its point on periphery. So if we take the second example, so what I can write? Time period 2 pi root under I by mglc. So 2 pi root under above the point of suspension, how much will become the moment of inertia? Above the center of mass, it is I center of mass is mr square. So from perpendicular axis theorem, I center of mass plus mr square. So this will come 2mr square divided by m into g into r done. So time period equals to 2 pi root under 2r by g. If I go for option C, they have an uniform square plate of edge A suspended through a corner. See then, a square plate is there. It is it has been suspended through the corner. So its moment of inertia for a square I center of mass. I center of mass is how much? Ma square by 6. What is side? Edge even. So moment of inertia I about this point. What I can write? I center of mass plus mr square. This distance will be how much? This distance will be a by root 2. So ma square by 6 plus ma square by 2. You can multiply with 3. So 4 ma square by 6. So 2 ma square by 3. So time period will become how much? 2 pi root under I by mglc. So 2 ma square by 3. And m into g and lc will become a by root 2. Done. So this will become 2 pi into root under 2 root 2a by 3g. If you see the last part of this question, they have an uniform disk of mass and radius are suspended through a point r by 2 away from the center. So if you take part D of this question, there is a circular disk and this is the center. It is at a distance r by 2 from here. Here it is hand. So about the center of mass, circular disk moment of inertia is mr square by 2. So I can write I center of mass plus mr square by 4 because distance is r by 2. mr square by 2 plus mr square by 4. So this will become 3 mr square by 4. So time period will become how much? 2 pi root under I by mglc. So 2 pi 3 mr square by 4 plus m into g. And what is lc here? R by 2. So done. R done. This 2 done. So 2 pi root under 3r by 2g. This will be the time period. So this is how you are supposed to do the problem related to the physical pendulum. Remember the few things we have to remember. I is about the point of suspension. LC is the distance of the point of suspension from the center of mass. These 2 points, if you remember, the question will not be difficult. So we have discussed this pendulum. Now let's understand energy in SHM. Energy in SHM. So we know in case of SHM, energy of the system remains constant. Means if SHM it is, energy will remain constant. We'll prove it also how it is. So what is the potential energy? Half kx square. So x equals to a sine omega t. So k a square sine square omega t. What we write? Omega equals to root under k by m. So k I can write m omega square. So half m omega square a square sine square omega t. I have taken phase constant here 0. That's why I'm not writing the term delta. Now kinetic energy, what we define? Half mv square. So half into m into v is equals to a square omega square cos square omega t. So what is the total energy in the system? Total energy is kinetic energy plus potential energy. So how much is the kinetic energy? Half m A square omega square cos square omega t. What is the kinetic potential energy? Half m omega square A square sin square omega t. So take common half m omega square A square sin square omega t plus cos square omega t. So this will come as half m omega square A square. This is the kinetic energy of the system. Sorry, energy of the system. And you know that omega is a fixed value. Omega is a characteristic property of the system. A is the amplitude, that is also fixed value. It is not position, it is amplitude. So that's why energy is a what? Constant value in case of SHM. That's what I told. See, if we draw the graph, these graphs have been asked few times. So if I draw the graph, and if we see the total energy remains constant. E remains constant here. This is potential energy. Remember this, at the mean position, kinetic energy is maximum. Right, in simple manner. Kinetic energy is maximum. This graph represents kinetic energy. You can see at the mean position, kinetic energy is maximum. At potential energy, this point, minus A plus A. So at this point, potential energy is maximum. Potential energy maximum. Here also potential energy maximum. Now at this point, potential energy minimum, but at this point potential energy will be 0. Sorry, at this point kinetic energy will be 0, and here also kinetic energy will be 0. See, I'm not saying potential energy will be 0, I'm saying potential energy will be minimum. So try to understand this thing by this example. If I consider a spring in horizontal plane, if there is a spring and it is in horizontal plane, what we did, we pulled it. So x equals to 0, this will be the mean position. So in mean position here, somewhere here extreme position will be there, plus A, and somewhere here this will be minus A. So here kinetic energy maximum, potential energy 0, kinetic energy 0, potential energy maximum, kinetic energy 0, potential energy maximum. Because at this point, see here, there is no extension in the spring. What is the mean position? Mean position is the point where net force is 0. Mean position is the point where net force is 0. Since there is no horizontal force acting, so there won't be any extension in the spring at the equilibrium position. But situation will change if I take the same spring in the vertical position, because in that vertical position, the spring on the spring, a gravity would be acting. So now see, if we take a spring, any spring is there of mass m. So what will happen? Due to gravity, some extension will be there. So kx naught here will be mg, So you can see that this is equilibrium position. Equilibrium position or mean position is the point where net force is zero. So somewhere if I pull it from the equilibrium position and leave it, it will start oscillating. So somewhere here will be minus A, and somewhere here will be plus A. So at this point, the potential energy will be maximum. At this point, potential energy will be maximum. At this point, kinetic energy will be maximum. At this point, kinetic energy will be zero, but at this point, the potential energy will be minimum, will not be zero, because there is some extension in this spring. But in the last case, it was not possible. So this was I was trying to convey. Yeah, the mean position, potential energy is not necessary to be zero, it should be minimum. But extreme position, kinetic energy necessary to be zero, body will not move away, otherwise it won't be the extreme position. So let's do few problem based on this. See, we have given a linear harmonic oscillator has a total mechanical energy of 200 joule. Potential energy of it at the mean position is 50 joule. Find all these values. See, exactly we got the similar question, but I have explained the last. But minimum potential energy is 100 joule, 50 joule. And what we can say, minimum potential energy plus K max, this will be the total energy. You can see in the diagram. Energy max will be what? Kinetic energy maximum plus U minimum, this will be maximum. Or potential energy maximum, because here kinetic energy is zero. So whatever this total energy is given here, so I can write it as a maximum potential energy, or at the mean position if I write, so I'll write as a minimum potential energy plus maximum kinetic energy. This will be the total energy. So we are given the potential energy is how much? 50 plus K max. This is equals to how much? 200 joule. So maximum kinetic energy will become how much? 150 joule. Minimum potential energy we have already got. Potential energy at the two extreme position. So 200, 200. Because at the extreme position, the energy, kinetic energy will be zero. So whatever energy you are having, that will appear as a potential energy. That's why the potential energy to two extreme will be how much? 200 joule. Let's take few more. See, they have again a particle execute SHM. They're asking what fraction of its total energy is kinetic and what fraction is potential when the displacement is 1/2 of its amplitude. So if I write potential energy directly I can write half kx squared. X is a by 2, so m omega squared, a squared by 4. So 1 by 8 m omega squared a squared. How to write kinetic energy? We need velocity. So see this equation I have written starting. V equals to omega square into a square minus x square. So omega, this is a square. X we have given as how much? A by 2. So a square by 4. So omega into root 3a by 2. So kinetic energy I can write as half mv square. So half into m into omega square. 3 by 4a square. So 3 by 8 m omega square a square. Then they're asking, this is the first part answer. Then they're asking at what point, at what value of displacement the kinetic energy and potential energy will be equal. So right then, They are asking the kinetic energy and potential energy should be equal. So K is equals to U. So half mv square cos square omega t will be equals to half m omega square a square sin square omega t. Omega square a square v square will be cancelled. Cancel, half cancel. So tan square omega t is 1. So tan omega t is 1. So they're asking at what value of displacement. So x I can write as how much? A sine omega t. If tan omega t is 1, means omega t is how much? Pi by 4. So x will be equals to A sine pi by 4. So A by root 2. So this is how we are supposed to do the problem related to the energy of the system. Now we'll understand combination of SHM. Case 1. If two SHMs, they are moving in a horizontal direction and they are combined. So we have given A1 is x is equals to case 1. Two are in the same direction. X equals to A1 sine omega t, and there is some position difference, so this will become phase difference. X equals to A sine omega t plus 5. And this will be A2. So at any instant position, what I can write? X1 plus X2. So A1 sine omega t plus A2 sine omega t cos, write this as a delta omega t cos delta plus A2 cos omega t into sine delta. So sine omega t, if I take common, A1 plus A2 cos delta, this will be sine omega t plus A2 cos omega t into sine delta. Now A1 plus A2 cos delta, I can write A sine, some different value, A sine theta. This A2 cos delta, this I can write as A cos theta. So if I write this as equation 1, this is equation 2. So if I write from 1 square plus 2 square, so A square cos square theta plus sin square theta. This will become A1 square plus A2 square cos square delta plus 2 A1 A2 cos delta plus A square cos square delta. So this will be how much? A2 sin delta it is. This will be A2 sin delta here. So this will be A2 square sin square delta. So this will become A square is equals to A1 square plus A2 square plus 2A1 A2 cos delta. So amplitude we can write as A is equals to root under A1 square plus A2 square 2A1 A2 cos delta. This is the thing. Now, since these two are combined, the phase constant will change, that we are writing as a theta. So if I write this as a cos theta and the other one as sin theta. Now, if I divide 2 by 1 from 2 divided by 1, so what I can write, tan theta will be equals to a2 sine delta by a1 plus a2 cos delta. Let's understand it. So we have given this question. A particle is subjected to two simple harmonic motion, x1 equals to a sine omega t, x2 is equals to sine omega t plus pi by 3. They're asking what is the displacement at t equals to 0, the maximum speed of the particle and the maximum acceleration of the particle. So what we can find first, amplitude. Amplitude of the resulting motion we can write as a1 square plus a2 square plus 2a1 a2. See the formula here, cos delta. So what is your delta? Pi by 3. So cos pi by 3. So this I can write as how much? a1 squared plus a2 squared. Cos pi by 3 is 1 by 2. So a1 a2. So at what is the phi value? See, if you want to find displacement at t equals to 0, directly I can figure out. At t equals to 0, this is a resultant amplitude. So at t equals to 0, x1 will get as how much? A sine omega into 0. So 0. x2 I will get as a2, that other term, sine. This term will be 0 plus pi by 3. So sine pi by 3 is root 3a by 2, and we know that x is equals to how much? x1 plus x2. So this will become how much? Root 3 a2 by 2. So this is what we will get. Now see the maximum acceleration of the particle. So what is maximum acceleration? A max is equals to a omega squared. They're asking magnitude. So a omega squared. So what is the resultant amplitude we got? a1 square plus a2 square. So a1 square plus a2 square plus a1 a2 to the power 1 by 2 into omega square. Omega we have. So this is how we are supposed to approach problem related to combination of SHM. So if the motion are happening independently in x and y, if x and y direction, in that case what will happen? So if we take case 2, one motion is happening is x equals to a1 sine omega t. The other one is y is equals to a2 sine omega t plus delta. So this is our equation 1. In first case, what was the situation? In first case was both the motions are in the same direction. Means that it could be next direction, both could be next direction, or both could be y direction. But both the motion are happening in one direction, means it's one dimensional. Not one dimension, means both the due to both the forces, the motion, the SHM motion is happening in the same direction. But here the motions are in due to one force motion is in a different direction, one force motion is perpendicular to the direction. So here, what I can write, y by a2 equals to sine omega t plus delta. So y by a2 equals to sine omega t cos delta cos omega t sine delta. So y by a2 sine omega t, what I can write, x by a1 into cos delta. Cos omega t, what I can write, 1 minus sine square omega t into sine delta. So y by a2 minus x by a1 into cos delta 1 minus sine square omega t, what I can write, x square by a1 square into sine delta. If I do square both sides, so I'll get y square by a2 square plus x square by a1 square minus 2xy a1 a2 cos delta sine square delta minus x square by a1 square sine square delta. Here cos square delta term I have missed. Now bring this term this side, and if you add, it will become 1. So y square by a2 square plus x square by a1 square minus 2xy a1 a2 cos delta equals to sine square delta. So in general case, the motion, if you see the trajectory of the particle, if they are doing SHM in two perpendicular directions, the trajectory of the particle will be a ellipse. But certain specific cases are there. In that case, it will be different. So those specific cases only they ask. So let's see those cases. Now case 1, if delta is equals to 0, so what will become? Y square by a2 square x square by a1 square minus 2x1 cos delta will become 0, cos 0 1 is equals to 0. So y by a2 minus x by a1 square, this is 0. So y is equals to a2 by a1 into x. So here if we see the path of a particle, it will look like a straight line at certain slope, and slope will be given by how much? A2 by a1. So your path of the particle will look like this. This is x-axis and this is y-axis. If I take second case here, case 2, del is equals to pi. So this will become how much? Y square by a2 square plus x square by a1 square. Cos pi is minus 1. So 2xy a1 a2, this is equals to 0. So y by a2 square, x by a1 square, this whole thing is square. So minus a2 by a1 into x. So here also if you see the resultant, the trajectory of the particle will look like a straight line. But this straight line would have slope negative. If you see this straight line, it has slope negative. And slope will be given by how much? A2 by a1. If I take del is equals to pi by 2, three special cases are there. If del is equals to pi by 2, so what it will become? Sine square delta will become 1. This term will become 0. So y square by x2 square, y square by a2 square plus a1 square, this is equals to 1 we are getting. So in that case, it will look like a ellipse. And in this ellipse, if you see, you can draw it. inside a rectangle. So if we draw this, so this ellipse, if you see this ellipse will be fixed in the boundary, and here if you see this will be minus a1, a1 minus a2 and a2. But here what will happen if a1 is 8 equals to a2? Here what we are getting trajectory as ellipse. If a1 is equals to a2, x square plus y square will be equals to a square is equals to a. Then trajectory will become what? Circle. It will be a circle, and its radius will be given by what? A. So these three possibility are there. In the third one, a special case is there. So if the two SHM you are combining, where both are due to both motions are in perpendicular direction due to those two forces. So in that case, the general motion comes as ellipse. But if we see a specific cases like delta equals to 0 and delta equals to pi, the trajectory will become a straight line. And they ask these specific cases when the trajectory is a straight line, delta values or delta value is this, what will be the trajectory. So here you can see the slope is negative, and if delta is pi by 2, the trajectory becomes ellipse. If delta is pi by 2 and a1 is equals to a2, in that case the trajectory becomes a circle. Now let's see, come to problem related to elasticity. What is elasticity? Elasticity is characteristic property of the material to get its shape back. Hence, if you apply some external force, body will be deformed, and once you remove this external force, body will try to regain its shape. This characteristic property of the material is called elasticity. If a body completely recovers its shape, then it is called perfectly elastic material. If body is not able to recover its shape at all, then it is called purely plastic material. Neither purely elastic material exists, neither pure plastic material exists. Whatever material is there, they are in the between these two ideal characteristics. So we can say if a body recovers its shape completely, then it is called perfectly elastic body. If a body is not able to recover its shape at all, then it is called purely plastic body. Now, till now, what we were saying in till rotational motion, if we see the study, we think about the rigid body. Rigid body means what? The point of separation between 2 points should not change in the body. Now we have come to the chapter elastic properties, where the 2 point between the 2 points, the point can be compressed or those 2 points can be elongated. So if these 2 points are compressed, that is body in the compressive stress. If body is those 2 points between 2 points, the distance has increased, the body is in the tensile stress. So let's understand these things. What is called stress? So stress, if we say, it is simply defined force upon area. So it is defined as force per unit area. There are two types of stress. One is normal stress, other one is tangential stress. So normal stress, where force is acting perpendicular to the area. Normal stress are also two types. One is compressive stress, the other one is tensile stress. So if you see tensile stress, what it is, suppose a body is there. On this body, two forces are acting, F, F. So here this body is what? This length is going to increase. So here this kind of a stress and force, you can see it is acting perpendicular to the area. So this kind of forces is called tensile force. But if the same body, the force is acting in opposite direction, so body will be in what? Compressive stress, because the length is going to be decreased. So if I say force is acting in this direction, here also force is acting in this direction, here it will become compressive stress. So sigma c is defined as force upon area. Now if we see tangential stress, what it is, so if the force act parallel to the surface, suppose if a body is there, on this body forces are acting in this manner. One force is here, tangential to the surface, another force is here. So you can see here this force is acting parallel to the tangential to the surface. So this leads to the tangential stress. So here we define also this tangential stress, or also we call it shear stress. So we write this sigma t or sigma s is equals to tangential force upon area. See here which area will take? We'll take this area. If you see here which area I'll take? I'll take this area. Normal area. Here tangential area we take to define the stress. Now After this, one more thing is there, that is called volumetric stress. Volumetric stress. So what is volumetric stress? Suppose a body is put inside a water where from all directions the forces will act. So in that case, there would be force from every direction. So here basically it will be the force that is here that will equivalent to the pressure. Sorry, this is bulk modulus will be equivalent to the pressure. So here we define this bulk modulus equals to force upon area, volumetric stress. Sorry. Now this is a stress. So when the length changes, that quantity we define strain. Here we define one quantity, that is strain. It is defined as it is a ratio of deformed, I would say, change in length by actual length. Change in length by actual length of the body. So see, if we say here also we define the same thing. The strain will be two types. One will be normal strain, another one will be tangential strain or shear strain. So if we see normal strain, so normal strain would be the body is there. So it might get deformed, it might get, if you say tensile strain in this normal strain. So tensile strain we define psi is equals to delta L by L. What is L here is actual length, initial length. If we say compressive strain, so what it would be? In this case, the length of the body will decrease by some value. Suppose this part would have decreased. This is delta L. This is the actual length. So here sigma c, this is sigma t. So here at what will be minus delta L by L. This is compressive strain. If we see shear strain, so what it is? Suppose a body is there in cubicle. Sorry for and cubicle C. Shear strain we are defining. So your body were here, and due to application of the force, one force F here, if it is fixed, opposite force will act. So if this dimension is x, this is L. So here we define this shear strain or tangential strain will be x by L. So this is what a strain. Here, based on this, the relationship that defines, that relates this stress and a strain, that is called Hooke's law. What is Hooke's law? It says that for a small deformation, stress is directly proportional to strain. So sigma is equals to E into C. E we define as sigma by C. Here E is called modulus of elasticity. So based on this relation, Hooke's law, some modulus, some this constant has been defined like Young modulus. It is for normal stress. So Young modulus says that it will be equals to normal strain by normal stress. Sorry, normal stress by normal strain. Then same way modulus of rigidity, modulus of rigidity. This is defined as G sigma T by psi T, tangential stress by tangential strain. Same way we define volumetric strain. So before volumetric strain, before and the modulus for the volumetric stress, we define a volumetric strain. So what is volumetric strain would be? So volumetric strain we can write as sigma V equals to delta V by V. So relation between volumetric stress and volumetric strain is defined by bulk modulus. It's a very important constant. It's a constant for a material. So bulk modulus is defined as volumetric stress by volumetric strain. So this volumetric stress is also equivalent to pressure, so delta V by V. Here one more term is there that is frequently means what some places will be used, that is called compressibility. So compressibility we defined as 1 by bulk modulus. Let's do few questions based on this. So see, we have this question. One end of a wire of 2 meter long and 0.2 centimeter square in cross section is fixed in ceiling and load of 4.8 kg is attached to the free. Find the extension of the wire. So what are the information we have given? We have given length is 2 meter. Area is 0.2 centimeter square. So 0.2 into 10 to the power minus 4. So 2 into 10 to the power minus 5. We have provided a load that is 4.8 kg. So I can write 48 Newton. You have given Young modulus. So Young modulus, what we write? Sigma n by psi n. So force by area into delta L by L. Normal strain is about delta L by L. So delta L I can write as how much? FL by A by force we have how much? 48. Length we have 2. Area we have given 2 into 10 to the power minus 5. Y value we have given 2 into 10 to the power 11. So 2 done. This is 24. So how much this will come? 24 into 10 to the power minus 6 meter. If we take one more problem, we have been find the decrease in the volume of sample of a water. From the following data, we have initial volume, initial pressure, final pressure, compressibility of the bottle. Here they were talking about some place instead of bulk modulus, they give you the compressibility in this data. So compressibility I can write as 1 by bulk modulus. So bulk modulus is 1 by K. So 50 into 10 to the power minus 11. So this will come 2 into 10 to the power 9 Newton per meter square. Now, what they're asking find the decrease in the volume. So what we write bulk modulus? P divided by delta P divided by delta V by V. So delta V I can write as delta P into V by B. So we have given change in pressure is how much? 9 into 10 to the power 5. And initial volume is how much? 1000 centimeter cube. So 10 to the power 3 into 10 to the power minus 6 by B. B we have given as 2 into 10 to the power 9. So 5, 4. This is 10 to the power 3. No. 5, this is 4. 10. So this will come how much? 4.5 into 10 to the power minus 7 meter cube. So this is the thing that we are supposed to do. Problem related to this. If we take one more problem, let's take this. We have been two long metallic strips are joined together by rivets, each of having 2.0 mm. Each rivet can withstand the maximum shearing stress of 1.5 into 10 to the power 9 pascals. They're asking what is the maximum tensile force the strip can exert. So, simple idea. Here we can use the shearing stress concept. So what we know shearing stress we define as tangential force by area. So they're asking maximum tensile force, so Ft. But see here what yes, so we have given the maximum shearing stress how much? 1.5 into 10 to the power minus 5. So sigma s into area. So we have given this maximum shearing stress as 1.5 into 10 to the power 9. And two areas involved. So this will come how much? Radius is 2 mm. So 2 into pi into radius is 2 mm. So this will come how much? 4 into 10 to the power minus 6. If we simplify this, that will be our result. After this, we'll understand stress strain curve. So what is stress strain curve? If we take a wire and pull it from both sides and slowly we study its behavior, that leads to the stress strain curve. So the graph I am drawing here, this graph is related to a elastic material. So first it goes to, for time being it will be remain straight for very small deflection. Here it is stress, here is strain. And then it will go in this manner and finally this. Here this point is called proportional limit. This is called maximum tensile limit. What is proportional limit? It's proportional limit, and this most of the time proportional limit and the elastic limit are same. But from the elastic limit, if we bring the body, it will recover shape and size. But proportional limit, most of the material it is same thing, but there is a small difference between these two, limit and proportional limit. So this is the stress strain graph for a body, for a ductile material. If it is a brittle material, what kind of graph it would be? If you draw a stress strain curve for the brittle material, so there won't be any deformation at all. It will break. But you can see this ductile material. Ductile material, the wire is what wire are made of those ductile materials. You can pull it. After this, we'll see elastic potential energy stored in the wire. Elastic potential energy stored in wire. So elastic potential energy stored in a wire is given as U equals to half into a stress into a strain into the volume. So half stress into a strain into volume. Volume you can write as area into the length. We know that we write y equals to sigma by psi. Sometimes they'll give only a stress or a strain, so you can manipulate these equations with this and can get the answer. Let's take few problems for this elastic potential energy. So we have given this, a wire of cross section 3 mm square, natural length 50 centimeters, fixed at one end, and a mass of 2.1 kg is hung from the other end. Find the elastic potential energy stored in the wire in steady state. So what we have again, a wire of area 3 mm square, length of the wire is 50 centimeter, and a mass is here of 2.1 kg is hanged. Find the elastic potential energy stored in the wire in a steady state. So what we know, U equals to half into stress into strain into gamma. So instead of calculating a strain I can write as sigma by gamma. So I can write half into sigma square into y into the volume. So half 1 by y value will be how much? They have the Young modulus of the material. So 1.9 into 10 to the power 11. This I can write force by area squared, stress, and this will become area into volume, volume area into length. So half into 1.9 into 10 to the power 11, force square into length by area. So half into 1 by 9 into 10 to the power 11. Force we have how much? They have it is 2.1 kg, so 21 newton, so 21 into 21. Length we have again 50 centimeter, so 0.5 by pi into r square. So radius we have again as how much? We have again directly cross section area, so 3 mm square. So how much this will come? 3 into 10 to the power minus 6. So this much joule, this will be the energy. Let's take one more problem. If I take this one, They have an uniform heavy rod of weight W, cross-sectional area A and length L is hanging from a fixed support. Find the elongation in the rod. See this they have given usually mostly problem they give the rod is massless. But if a rod is having certain mass, so then what will happen? At every point the tension will be different. So suppose at a distance x here, if I want to write the stress. So sigma value will be given by how much? Force by area. So I can say L length have a W. So X length would have W, weight how much? W by L into X. So W by L into X into G by area they have given as A. So what they're asking find the elongation in the rod. So what we can write then? Y is equals to force by area into delta L by L. So delta L if you want to write, you should write YAL. Delta L if you want to write YAL by F. This will become the extension. So we have given these all these values. So if you want to write here, we need to calculate the extension in the rod. Okay, wait. In this relation here, delta is in the denominator. So we can write here this delta L by L. So delta L will be how much? FL by AY. So since small element in this a small element we are considering, so to calculate delta L we have to integrate for this problem. So force we have given how much? W by L into G into X by Y. So what I can write? WG by ALY integration of what? X dx. Correct. The length we are considering here, the small element length is how much? Dx. So this will become how much? WG by ALY x square by 2. From where to where? 0 to L. So WGL by 2AY L square. L will be cancelled out. So this is the thing how you can do the problem related to the energy stored in case of the rod due to its own weight. So it's completion of this today's lecture, this elasticity and SHM. Thank you.